Hello, welcome back. I am Rajendra Badi, and in this video you will study orthographic projections part 1, fundamentals of orthographic projections. Now listen to me very carefully. To define position of a point in space or position of an object in space, space is imagined divided in 4 quadrants, and for that purpose two perpendicular reference planes are considered. A vertical reference plane, that is VP, and a horizontal reference plane, that is HP. Intersection of VP and HP, that is XY line. So on drawing paper, a horizontal reference line is XY line and it is a line of intersection of HP and VP. Primary position of observer is considered in front of VP and observing the object in the direction perpendicular to VP. So with reference to this position of the observer, the 4 portions of the space made by these 2 reference planes are defined in this manner. Portion in front of VP and above HP, that is first quadrant. Portion behind VP and above HP, that is second quadrant. Portion behind VP and below HP, that is third quadrant. And portion in front of VP and below HP, that is fourth quadrant. Now object is imagined either in the first quadrant or in the third quadrant. Now here in this diagram, it is first quadrant considered. Now this object is in the first quadrant. Now a very important thing. Remember, when it is a machine part, a 3-dimensional body, when it is imagined in the first quadrant or in the third quadrant to draw its views, it is placed in such a way that its major surfaces are parallel to the reference planes. For example, here it is simplest possible 3-dimensional body is considered a rectangular block. In this case, the rectangular block is placed in such a way that its major surfaces are parallel to VP, parallel to HP. Its top surface, check, it is parallel to HP. Its front surface, check, it is parallel to VP. So this is how an object is placed so that its major surfaces are parallel to reference planes. Now here it is only third quadrant is shown, and now object is in the third quadrant, means it is behind VP and below HP. Object is observed in the direction perpendicular to reference planes. So this direction is perpendicular to VP. In this direction we get front view of the object, and in this direction you get top view of the object. This direction of viewing the object is perpendicular to HP. Now listen to me very carefully. When an object is observed in the direction perpendicular to a reference plane, then the view you get is orthographic view. That is, front view is an orthographic view. Top view is an orthographic view. When object is imagined in the first quadrant and views are taken, that is first angle method of projection. This is the direction again perpendicular to HP. You watch an object in the direction perpendicular to HP and you get top view. Watch object in the direction perpendicular to VP and you get front view. So now imagine these 2 planes, transparent planes. You are watching from front and you can see front side of the object. This is third angle method of projection. In first angle method of projection, object is always in between observer and the reference plane. Listen to me very carefully. In first angle method of prediction, object is always in between observer and the reference plane. But in the third angle method of prediction, reference plane is in between observer and object. Check again. Observer and object, in between these two, the reference plane is. In subsequent videos, we are going to study, or we are going to use first angle method of prediction. So we'll focus on first angle method of prediction now. Now here it is first quadrant considered. Object is in first quadrant. When you view object in the direction perpendicular to VP, and whatever you can see when you draw behind the object on the VP, the view is is front view. It is also called projection on the VP. So view in VP or projection of object on the VP, that is front view. When you watch object in the direction perpendicular to HP, and whatever you can see, all those details to the scale you draw on the HP, that is projection on HP, nothing but top view. Sometimes, or rather many times, front view and top view are associated with side view. To draw side view, one more reference plane is considered, which is perpendicular to VP as well as HP. Such a plane which is perpendicular to both the reference planes, VP and HP, that is side plane or profile plane. In short, PP. When you watch object in the direction perpendicular to PP, you get side view. You watch object in the direction perpendicular to PP, and whatever you can see, you draw on PP. That is projection on profile plane, nothing but side view. So front view, top view and side view are orthographic views. So here it is the three-dimensional block and its views: front view, top view and side view. In three-dimensional view, all three dimensions you can see: length of object, width of the object and height of the object. But in the views, in projections, orthographic projections, in each view you get only two dimensions. In the front view, length and height. In the top view, you get these two dimensions, length and width. And in the side view, you get two dimensions, height and width. If you want to know all three dimensions, or you may say that to understand size and shape of the object, minimum two views are required. These two views can be front view and top view, or front view and side view. And many times all three views are considered. To bring all these three views in one single plane, we imagine opening of the quadrant. Now in this case, HP is rotated about line of intersection of VP and HP to bring HP in the plane of VP, and profile plane is also rotated about line of intersection of VP and PP to bring the profile plane in the plane of VP. So now all these three planes are in one single plane, and this is our drawing paper. Intersection of VP and HP, that is XY line. Intersection of VP and PP, that is X1, Y1 line. So on drawing paper, this is our drawing paper. On drawing paper, XY line appears horizontal and perpendicular to XY line, that is X1, Y1 line, which is line of intersection of VP and PP. So this is vertical plane, that is VP. Below VP, that is horizontal plane, HP. And here it is profile plane. It is on the right side, and that is why it can be considered as right side vertical plane. or right side plane. Now view in VP is a front view. So this front view appears on the drawing paper above XY line. It is two-dimensional view where you can see length and height. In the top view, you get the two dimensions of the object, length and width. Since it is the same length appears in the top view, you can directly project that length. So these two lines are called end projectors from extreme right end and left end of the front view. These are called end projectors. So this is how we transfer length in the top view. We measure width vertically, and this is how this is top view of the object. So front view and top view have common end projectors. Remember, this is very important. Basic logic is two views of a point, front view and top view. Two views of a point lie on single projector. Similarly, front view of an object and top view of object have common end projectors. Okay. Now to draw side view of the object. Which two dimensions we get in the side view? Width horizontally and height vertically. So height is vertical. In the side view also height vertical. Transfer it by drawing horizontal projectors. So this is how we have drawn end projectors. These are called end projectors from front view to side view. These are horizontal lines perpendicular to x1, y1 line. So this is how you have transferred height in the side view. Now in the side view, width appears horizontally and in the top view, width appears vertically. So how to transfer width in the side view? So there are different ways. You may draw such quarter circular arcs. To draw these arcs, center is intersection of xy line and x1, y1 line. Projectors are always perpendicular to xy line and x1, y1 line. These two projectors are perpendicular to x1, y1 line. So this is how width we have transferred on x1, y1 line. Now this width becomes horizontal in the side view. And to transfer this width horizontally here, these two quarter circular arcs are drawn. And for both these arcs, these are concentric arcs, and for both the arcs, center is intersection of xy line and x1, y1 line. There is one more method. You may draw a line perpendicular to, at an angle 45 degrees to xy and x1, y1 line. So this line is at an angle 45 degrees drawn to xy line and 45 degrees to x1, y1 line. Now extend these projectors up to that 45 degrees line and then bend by right angle. And this is how you have transferred this width in the side view. So this width has appeared horizontally in the side view. There is another method to transfer this width. You may draw these lines. These lines are at an angle 45 degrees again with xy line and x1, y1 line. Now this vertical width in the top view appears horizontal here in the side view. So no change in dimension at all since you have used at 45 degrees angle. 45 degree, 45, 45, 90. This right angle triangle is isosceles triangle. The same length which is vertical here appears horizontal here. So this vertical width here in the top view appears horizontal in the side view. So to transfer or to project width in the side view, you may use this method. It's your choice, any method you may use. In manual drawing, not in AutoCAD, but in manual drawing, I prefer quarter circular arcs. So this is how the width is transferred in the side view. And side view is complete. So in the side view, the two dimensions you get, width horizontally and height vertically. So remember once again, in isometric view, height is vertical, length is at an angle 30 degrees and width is also appear at an angle 30 degrees. In isometric view, length appears at an angle 30 degrees, width appears at an angle 30 degrees. But in orthographic views, in front view, length horizontal, height vertical. In the top view, length horizontal, width vertical, and in the side view, width horizontal and height vertical. Now this change in orientation of length and width in isometric view and in orthographic views, that is very important and you should understand. Remember, in the top view, width appears vertical, and in the side view, width appears horizontal. Now front view, top view and left side view. In first angle method of prediction, as you know now, that is top view appears below front view and left side view appears on the right side of front view. Now these three views are of this object. Now length doesn't mean longest dimension. Length means dimension of the object parallel to length axis. Now in this isometric view, do you know where are the three axes? So try to understand. The direction in which observer observes object for front view is indicated in this manner. Always an isometric view is associated with such an arrow. That arrow suggests you front side of the object. So this side is a front side of the object. Now parallel to this arrow dimension is width. The direction of observation for front view parallel to this direction is width. This is length then, and vertical axis is always height. So height axis is vertical and length and width axis appear at an angle 30 degrees in an isometric view. Isometric view is three-dimensional view. Now with reference to length, width and height axis, we define 6 ends of object. Front side, back side. Try to understand, this rectangular surface is front surface of the object and this rectangular surface is backside surface of the object. So front, back, left side and right side. So this is left side of the object, this is right side of the object. Check, these two arrows are parallel to length axis. So dimension from left to right, that is length. Dimension from front end to back end of the object, that is width. And dimension from bottom end to top end. So this is top side and this is bottom side. So from bottom to top, that is height of the object. These two arrows indicating top side and bottom side, note here, are parallel to height axis. So we say that with reference to length, width and height axis, there are 6 sides of the object: front, back, left, right and top, bottom. And this is how in this three-dimensional view we could show all 6 ends of the object using such arrows. But in orthographic views, since these are two-dimensional views, you cannot indicate all 6 sides in one single view. Try to understand what I am telling you. This front surface appears here in the front view. Where is back surface? So it is overlapping on the front surface. So in front view, front and back overlap. Front surface and back surface cannot be separated in front view. But this end is right end and this end is left end. This is top surface and this is base surface. All these other 4 surfaces appear lines in the front view. So this is right side of the object, this is left side of the object, this is top side of the object and this is bottom side of the object. And what you are watching here is, that is front side of the object, and same is the back side of the object which is hidden behind this front side. So front side and back side cannot be separated in the front view. But other 4 sides you can indicate clearly. This is right side, left side, top side and bottom side. Similarly in the top view, try to understand here. This is right side and here it is left side. Where is the front side? So remember, this is top view. So you are watching this object from top. So right now on the screen, the direction in which you are watching the top view, that is top surface. So top surface and bottom surface overlap in the top view. This is front side and this is back side of the object. So what I want to tell you here is, in the front view, front back overlap and cannot be separated. But other than front and back, 4 sides you can identify or show in this manner: right, left, top, bottom. In the top view, top and bottom cannot be differentiated, they overlap. But other 4 sides, so right, left, front and back, can be shown using these arrows. Now front side appears here in the side view. So this vertical line is front end of the object. So accordingly this is back end of the object. So front, back, top and bottom. So this top surface in the side view appears at the top. If you drop projectors, this is how you get it, at the top. And this front surface, when you imagine projector from top view to side view, will appear here. So this is front side of the object, this is back side of the object, this is top side of the object, this is bottom side of the object, left side and right side overlap here in the side view. So remember, you cannot show all these 6 sides in orthographic views. In each orthographic view, you can show only 4 sides. In the front view, listen to the statements I am now making. In the front view, front, back overlap. In the top view, top, bottom overlap. And in the side view, left side, right side overlap cannot be differentiated. But in the front view, front and back overlap, but other 4 sides, that is right, left, top, bottom, can be indicated. In the top view, this is right side, left side, back side and front side. And in the side view, you can indicate all other 4 sides: front, back, top and bottom. How it is going to help you? This is very important to know. When it is a machine part, there will be very small details involved: holes, oil holes, keyholes, slots, cylinders, plates, etc. So relative position of all these portions or parts of a machine, you must be able to identify in an orthographic view as well as in isometric view. Now let's have few examples. Here is point O. Where exactly this point O, let's define with reference to length, width, height axis, or with reference to these 6 sides of the object. This point O is on the left side, but that is not enough. Left side, so there are so many corners. That's the entire surface is on the left side. Point O is on the left side. It is at the bottom. So left side and bottom, but that's also not enough. Left side, bottom, this complete edge is on the left hand side and also at the bottom. So we say that this corner is on the left hand side, at bottom and at front. So with reference to all these 3 axes, length axis, width axis and height axis, we can define position of point O in this manner with reference to this body. This point O or corner O is on the left side, at bottom and at front. So where is this O in the front view? So it is on the left side. So this is the left side of the object. And it is at bottom. So here it is point O. Now point O is also on the front. But remember, front, back are not significant in the front view. Because in front view, front and back cannot be differentiated. They overlap. So when you are identifying position of point O in the front view, check whether it is at top or bottom, whether it is on the left side or right side. So point O is on the left side and at bottom, therefore point O is here. Now let's look at point O in the top view. In the top view, don't worry about whether point O is at top or bottom, because you cannot differentiate top bottom in the top view. In the top view, top bottom overlap. So to locate point O in the top view, what you are going to check, whether it is on the left side or right side, and then whether it is on the front side or back side. So point O is on the front side, so here. And at the same time it is on the left side, so here. So on front and on left simultaneously, that is this corner. This corner is point O, which is on the left side as well as on the front side. Now to locate point O in the side view, don't check whether point is on the left side or right side, because left side, right side you cannot differentiate in the side view. So to locate point O in the side view, what you will check, whether it is on the front or back, whether it is at top or bottom. So check here, point O is at bottom. So here point O is somewhere. Point O is at the front also. So front bottom, that is this corner. This corner is point O. So this is how we can locate point O in orthographic views. Few more examples. Now here it is point A. So point A is on the right side. So on the right side and at bottom. So this is point A. In the top view, check whether it is on the front, back, left or right. So point A is on the right side. So here, and it is on the front. So this is front side. So here it is point A. Now let's check where is a point A in the side view. Point A is on the, but wait. Point A is on the right side. Has no significance when you want to know point A in the side view. In the side view, right, left, you cannot differentiate. So you should check whether point A is on the front or back. So point A is on the front side. And then you check whether point is at top or bottom. So point A is at bottom. So the same point, this corner is point A. It means in the side view, point O and point A overlap. So point O and point A overlap in the side view. So this corner is not just a point. This corner is edge OA, which appears point in the side view. Few more examples. Here it is point B. Point B is on the left side. So here. And at bottom. So here. So left and bottom, that is point B is here. In the top view, let's look at point B. Point B is on the left side and it is on the back side. So here it is point B on the left side and on the back side. So this corner is point B. Now point B is at bottom and at the same time it is on the back side. So here this corner is point B. Point C is on the front, but in front view, front back are insignificant. So to locate point C in the front view, check whether it is at top or bottom. So point C is at top and it is on the left side. So here it is point C. In the top view, point C is, check here, point C is on the left side and on front. So this is left and this is front. So C point is this corner in the top view. So in top view, corners O and C coincide or overlap. And this edge OC appears point in the top view. It's vertical edge perpendicular to HP. And you know that when line is perpendicular to HP, it appears point in the top view. So this corner is actually edge OC. Now, let's look at point C in the side view. So it is on the left side, don't worry about that. For side view, check whether it is on front or back. So it is at front and it is at top also. So this corner is point C. This corner is point C. Now point D. Point D is on the right side and at top. So this is point D is on the right side and at front. So top view, here it is point D. A and D coincide, or you may say edge AD appears point in the top view. Point D is on the right side, but that is insignificant in side view. For side view, you should check front, back, top, bottom. So point D is on front side. So this is front side. And at the same time, point D is at top. So front and top, that is this corner is D. So CD coincide in the side view. That means the entire edge CD appears point in the side view. So this corner is not just a corner or a point. This corner is edge CD, which appears point in the side view. E is at top and on the left, so this point is E. Point E is on the back side and on the left side, so this corner is point E. And point E is on the back side and at top, so this corner is point E. Now let's look at point F. Point F is on the right side and at top. Point F is on the back side and on the right side. So here it is point F. And point F is on the back side. So here and at top. So point F is on the back and at top. So here it is point F. So these are points we have located in the front view, top view and side view. It's very important exercise we did here. Now let's talk about symbols for first and third angle method of projections. This is a symbol used for first angle method of projection. And this is symbol used for third angle method of projection. What exactly it is? Let's study. These are views of a frustum of a cone or a truncated cone. When cone is cut by a plane parallel to its base, then the section you get is smaller circle. When apex portion is removed and portion on the base side is retained, that retained portion is called frustum of a cone. Now center of smaller circular end and center of larger circular end, if you join, then that is axis of the frustum of the cone. Now here cone is placed in such a way that axis is parallel to HP and as well as VP. This is front side of the object. So in front view, it appears a trapezium. And this smaller circular end is visible from left side view. Top view is not drawn here, but this is left side. So from left side, smaller circle is visible. And of course, larger circle is at boundary, so it is visible. So smaller circular end and larger circular edge both are visible from left. So this view suggests, these two views suggest you, that is, left side view is drawn on the right side of front view. That is first angle method of projection. So when we use first angle method of projection, we need not mention it in words. Instead, we draw just these two views of frustum of a cone. This symbol suggests that the first angle method of projection is used in that particular drawing sheet. Now watch this diagram. In this case, left side view is drawn on the left side of front view. That means in this diagram, third angle method of projection is used. So if third angle method of projection is used in drawing sheet, then this symbol is used in corresponding drawing sheet suggesting third angle method of projection. Of course, as you know, we are going to use first angle method of projection only. Thank you for watching video. We'll meet soon in my next video. Till then, bye bye. Take care.